Let's do another example. So the previous example was a class A on the 4th octet. This time we're going to do a class A on the 3rd octet. And this one can get a little bit confusing, so you might need to pay attention to this one again. So in our example, we've been allocated class A 60.0.0.0/8. If we subnet it into /19 networks, how many subnets do we have and how many hosts per subnet? So pause the video again and figure out the answer, and I'll see you back here with the answer. Okay, /19 is, the line is going to be after 3 bits on the 3rd octet. So that leaves us 13 bits for hosts. 8 in the last octet, and then 5 on the right-hand side of the 3rd octet. So to figure out how many hosts each network is going to support, it's 2 to the power of 13 minus 2. So that's 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, then 2048, 4096, and 8192 minus the 2 gives us 8,190 hosts per network. And because we were allocated a class A /8 range, the difference between a /8 and a /19 is going to be 11 bits. So to figure out how many networks we have, it's 2 to the power of 11. So we already know 2 to the power of 10 is 1024. So we'll double that again. That gives us 2048 subnets. As usual, we've got the second part to the question. So for the IP address 60.15.10.75/19, what's the network address, the broadcast address, and the range of valid IP addresses? Please pause the video as usual, and I'll see you back with the answer. Okay, this example we are subnetting on the 3rd octet. The other examples we've been subnetting on the 4th octet. The line is after the 32 on the 3rd octet, so the network block addresses are still going to go up in multiples of 32, but it's going to be on the 3rd octet rather than the 4th octet now. So our network address is 60.15.0.0. You can see it if you write out the whole IP address. Also, we're 60.15.10, we're going up in multiples of 32, so obviously 10 is less than 32, so the network address must be 60.15.0.0. The next network address would be 60.15.32.0. So the broadcast address is going to be 1 less than that on the 3rd octet and 255 on the 4th octet. So the broadcast address is 60.15.31.255. And the valid host addresses will be between the network address and the broadcast address. So that's 60.15.0.1 up to 60.15.31.254. Okay, so the value on the 4th octet is the lower range is going to be a 1, the higher range is going to be the 254 for the hosts. The subnetting is done on the 3rd octet if the subnet mask is anything between a 16 and a 24. We can use the magic number method for that example again. It was a /19, so /19, that's 3 bits on the 3rd octet. So that is 128, 192, and then 224. We subtract 224 from 256, which gives us 32, so that we know that the address block is going up in values of 32. Again, it's on the 3rd octet rather than the 4th octet here. So we can figure out the same as we did in the previous slide from that it must be a network address of 60.15.0.0 because our value in the 3rd octet is 10. The broadcast address, 1 less than that, 60.15.31.255. Valid host, 60.15.0.1 up to 60.15.31.254. Okay, review this example again if you're not sure about doing it on the 3rd octet. Remember, we figure it out exactly the same way as we did when we were doing it on the 4th octet. So the address block is figured out exactly the same way again. You just need to remember that on the 4th octet, your hosts are going to go from 1 on the low end up to 254 on the high end. Okay, let's do one more example. So you've been asked to subnet the 134.65.0.0 network into 6 different networks. What subnet mask are you going to use? Please pause the video and figure out the answer. Okay, before I show you the answer on the next slide, let's see how we would figure this out. The network is 134.65.0.0, so we know it's a Class B network. And we need to split it into 6 networks, so we're going to need 3 bits because it's 2, 4, 8. It's a Class B, so the default subnet mask is a /16. We need 6 networks, which was 3 bits, so we add 3 to the /16, and that will give us a /19. So very easy to figure this one out. And that's showing it there with the line on our diagram as well. Some extra information that we weren't actually asked for in the question. A /19 in dotted decimal is 255.255.224.0. The network addresses would be going up in blocks of 32. So 134.65.0.0, the next one 134.65.32.0, etc. And we would have 8,190 hosts in each subnet because we've got 13 bits available for the host address. 2 to the power of 13 minus 2 is 8,190. Okay, so that's just done for all of the different examples of subnetting. Hopefully you're confident with this now. You should be. If you've worked through all of those examples, then you're going to be fine when you do the exam. When you are on the exam, there's lots of different ways that they can ask you questions about subnetting, but it's all going to boil down to just a few things, which you can see here. So it could be a variation of, given a network requirement of X amount of subnets and Y amount of hosts per subnet, what network address and subnet mask should you be using for each subnet? The other basic question they can ask is, if they give you a particular IP address and subnet mask, calculate that subnet's network address, the broadcast address, and the range of valid host IP addresses. So again, it could be any variation on those questions. They might ask it in a different way, but as long as you can answer those questions, which you can now because we've done loads of practice examples of them, you're going to be fine for anything that they throw at you on the exam. Okay, so that's our subnetting done. We've still got a bit more to talk about IP addressing though, starting with private addressing in the next lecture.